Okay, let's have a look at exercise 6.6 from the IGCSE ratios topic. And this is going to be question 3. And it says a drawing measuring 10 by 16 centimeters needs to be enlarged. Well, I'm going to draw that up first of all. So we've got 10 by 16. There it is. So I've got 10 centimeters there and 16 centimeters there. So that is the ratio of one side to the other, 10 to 16. And it says the dimensions of the enlargement need to be 25 by 40. So 25 by 40. So across now, it's not going to be 10. And by the way, this is not to scale, okay? This is now 25, and this is 40 high. So we've certainly enlarged it. Interestingly, let's just make sure that the proportions are the same. The ratio of one side to the other, the ratio of one side to the other. Well, the ratio of one side to the other is 16 to 10. Let's just see. So I got 16 to 10. Let's simplify that. Let's divide all of that by 2. That would be 8 to a half of 16 is 8, half of 10 is 5. Well, let's see if that's true for this one as well. So this one here is 40 to 25. Let's see if that's the same ratio. Well, I can divide that by 5. 5 eighths are 40, and divide 25 by 5. 5 fives are 25. Oh, look, same ratio, but one of them is a whole bunch bigger than the other. Because these are the same ratios, we can say the ratio of 40 to 16 is the same as the ratio of 25 to 10. And what is the ratio of 25 to 10 or 40 to 16? So we're comparing one to the other, one to the other. And as long as we're comparing the same sides, so whatever you do, don't go and compare 40 to 10 or 16 to 25, because you're not comparing like with like. So let's compare the widths, 10 to 25. So we're comparing 25 to 10. Well, let's express that as a ratio, as a rational number. Well, 25 over 10 equals 2.5. And what we just found is the factor of enlargement. That's what we call factor of enlargement. Enlargement. Or if you like to call it the scale factor. Now, it means that this one here is 2.5 times larger than this one, or this one's 2.5 times smaller than this one. And the same must be true, by the way, for 40 over 16. So if I said 40 over 16, and I divide 16 into 40, I'm going to get again 2.5. So it holds true. It doesn't matter which way around you do it, provided you compare like with like, same with same. Now, we can't claim, though, that the ratio is 2.5 compared to 1. It would be useful to say the ratio is actually 2.5 to 1. Now, you can do that, but generally speaking, ratios, we use whole numbers. So what we need to do is convert these to the nearest whole numbers. So if I was to multiply this by 2, that would become 5. And I multiply this one by 2, and I would get 2. So we can say that the ratio of one to the other, the ratio of the larger one to the smaller one, is a ratio of 5 to 2. And that would be the answer.